Hello friends, this video on gravitation part 1 is brought to you by examfear.com. No more fear from exams. Topics which we'll cover in this lesson are Introduction, Universal Law of Gravitation, the Gravitational Constant, Acceleration due to gravity of the Earth, Acceleration due to gravity below and above the surface of the Earth, Gravitational potential energy, Kepler's laws, escape speed, Earth satellites, energy of an orbiting satellite, geostationary and polar satellites, and weightlessness. So let us start with what is gravitation. All of us would have observed such phenomenon like an apple falling down the tree to the surface of the ground. But there is a mystery behind what makes the apple fall to the ground. Similarly, you would have seen that when you throw a ball up, it comes back and falls in your hand. Similarly, in a rainy season, the raindrops, that is the water droplets, fall towards the ground. If you see, in all these phenomena, there is some force which is responsible for the objects falling towards the surface of the earth. So these were the examples which we see around us in the terrestrial world. Even if you see in the universe, if you see the planetary motion, there is some force which holds the planets in a particular orbit. We all know that all the planets move in a particular orbit. So this specific orbit of the planets are also held by certain kind of forces. So gravitation is responsible for all such phenomena. Gravitation is nothing but a force which is exerted by the surface of the earth. So in this chapter, we will study in detail all the principles of gravitation. We'll see how was the law of gravitation brought into the picture of science, and we'll study all the planetary motion as well. So let us go ahead and see what made the origin of gravitation. Introducing Newton's view towards gravitation. So Newton was the scientist who actually studied about gravitation. In fact, he was the one who thought about what is gravitation, and he defined the force of gravitation. So how did this idea click Newton? It once happened that Newton was having a cup of tea in his garden when he saw an apple falling down the tree to the ground. So Newton thought, what made this apple fall to the ground? He did lots of studies and investigations. He performed several experiments and finally concluded that there was a force which is exerted by the surface of the earth, because of which the apple gets attracted towards the surface of the earth and falls towards it. But then, when he performed so many experiments, he concluded that it was not only the surface of the earth which exerts force on an object. In the entire universe, all the objects exert a force on another object. That means all the objects in this universe attract every other object with a force. So this force was nothing but the force of gravitation. So this is how Newton deduced the idea of gravitation, and he defined the force of gravitation, which later came to be known as the famous universal law of gravitation. So we'll start this chapter with universal law of gravitation. So universal law of gravitation. What does this law states? See, if you see the name of the law, it is universal. That means it is true for everything. Something which is universal is something which is applicable to all the objects in this universe. So this law states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That means that any object which you see around us or which you can think of in this entire universe attracts every other body. So there is a force of attraction between any two bodies in this universe, and this force of attraction is directly proportional to the product of their masses. That means the product of the masses of the two bodies and it is inversely proportional to the square of the distance between them. What do you mean by directly proportional and inversely proportional? When I say directly proportional, I mean that if the product of the masses increases, the force will also increase. When I say inversely proportional, I mean if the square of the distance increases, the force will decrease. That means if two objects are directly proportional, that means the two objects increase or decrease together. Similarly, if two quantities are inversely proportional, that means if one quantity increases, the other quantity decreases. So let us see. Let us suppose we have two objects. Say this is a ball of mass m1 and this is a box of mass m2. Now according to universal law of gravitation, even these two objects tends to attract each other with a force, say F, let that force be F, which is directly proportional to the product of the masses, that is m1, m2, and it is inversely proportional to the square of the distance between them. So we considered m1 and m2 are two masses. Let us suppose the distance between them is r. Then the force of attraction between them is directly proportional to the product of the masses. That means if m1 or m2 increases, this force will also increase. Similarly, it is inversely proportional to the square of the distance. That means closer these two objects come, the force will be more, because as close as they come, the value of r will decrease. Now value of r decreases means the value of F will increase. So this was basically the universal law of gravitation, which was given by Newton, and it holds true universally for all the objects in this universe. Now let us see the mathematical expression for the universal law of gravitation. Just now I told you in the previous slide that the force of gravitation is directly proportional to the product of the masses, that is m1, m2, and it is inversely proportional to the square of the distance between them. Now we know that means from these two we can say that force is directly proportional to m1, m2 divided by r square, correct? Now to convert this proportional to an equality, we need to introduce a constant. That is, we can write this as F is equal to some constant into m1, m2 by r square, right? Now what is this constant? This constant is nothing but capital G, that is the universal gravitational constant. So we say that force is equal to G m1 m2 by r square, where G is known as the universal gravitational constant and it is universally constant. That means its value, the value of G, remains constant everywhere in this universe. This value will never change. So this is basically the mathematical expression of the universal law of gravitation, where G is the universal gravitational constant, m1, m2 are the masses of the two bodies, and r is the distance between them, right? Now, thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.